The James Webb Space Telescope just captured something that has NASA scrambling to cut their live feed, and what they found in the depths of space is making scientists question everything we thought we knew about our universe. I'm talking about a structure so massive, so perfectly organized, that it shouldn't exist according to our current understanding of cosmic evolution. And the fact that NASA immediately went dark after this discovery, that's raising some serious questions about what they're not telling us. What you're about to see will fundamentally change how you think about our place in the cosmos. This isn't just another pretty picture from space. This is evidence of something that challenges the very foundations of modern astrophysics. So buckle up, because we're diving deep into one of the most mind-bending discoveries in the history of space exploration. The James Webb Space Telescope has been revolutionizing our understanding of the universe since it began operations. This incredible machine can peer further into space and time than any instrument humanity has ever built, capturing light from galaxies that formed when the universe was just a cosmic infant. But nothing prepared scientists for what they discovered during a routine deep-field observation last week. The telescope was conducting a standard survey of what astronomers call the cosmic web, the large-scale structure of the universe that looks like a vast network of filaments connecting galaxies across billions of light-years. These cosmic highways of dark matter and ordinary matter form the backbone of everything we see in space, creating a web-like pattern that stretches across the observable universe. But as the data came in from this particular observation, something immediately stood out. There, embedded within the cosmic web, was a structure unlike anything ever documented. We're talking about a formation that spans over 200 million light-years across minus. That's roughly 2,000 times wider than our entire Milky Way galaxy. To put that in perspective, if our solar system were the size of a quarter, this structure would be larger than the entire state of Texas. What makes this discovery even more extraordinary is the structure's organization. This isn't some random collection of galaxies scattered through space. Instead, it appears to be arranged in a highly ordered, almost geometric pattern that defies conventional explanations for how matter should be distributed in the universe. The galaxies within this structure are aligned in ways that suggest some kind of organizing principle that we don't currently understand. The moment this data started coming through NASA's systems, something unprecedented happened. The live feed that had been streaming the telescope's observations to research institutions around the world was abruptly terminated. Scientists who had been monitoring the data in real time suddenly found themselves staring at blank screens. Official channels went silent, and NASA's public communications team started issuing carefully worded statements about technical difficulties and routine maintenance. But here's where things get really interesting. Multiple independent sources within the astronomical community have confirmed that the feed cutoff wasn't due to any technical problem. According to insiders who spoke on condition of anonymity, the decision to terminate the stream came from high-level administrators who were apparently concerned about the implications of this discovery becoming public before it could be properly analyzed and contextualized. Think about that for a moment. NASA, an organization that has built its reputation on transparency and public education, decided to cut off access to data that could represent one of the most significant cosmological discoveries in human history. That alone should tell you just how monumental this finding really is. The structure itself appears to exhibit characteristics that shouldn't be possible given our current understanding of cosmic evolution. According to the standard model of cosmology, the universe began in a nearly uniform state after the Big Bang, with only tiny density fluctuations that gradually grew over billions of years to form the galaxies and larger structures we see today. This process should result in a fairly random distribution of matter on the largest scales, with some clumping but nothing approaching the level of organization observed in this new structure. What Webb has apparently discovered challenges this fundamental assumption. The structure shows signs of having formed much earlier in cosmic history than should be possible, and its geometric arrangement suggests processes at work that aren't accounted for in our standard models. Some preliminary analyses suggest that the formation could only have achieved its current configuration if there were additional forces or mechanisms operating in the early universe that we haven't yet identified. The timing of this discovery is particularly significant. The James Webb Space Telescope has already been forcing astronomers to revise their theories about early galactic formation, stellar evolution, and the behavior of supermassive black holes. Just when scientists thought they were getting a handle on these new revelations, this structure appears and throws everything into question once again. Several independent research teams have been working around the clock to analyze the limited data that was captured before the feed was cut. What they're finding is even more intriguing than the initial observations. The structure appears to contain galaxies that are much older and more developed than they should be for their distance from us. Remember, when we look deep into space, we're also looking back in time. The light from these distant galaxies left them billions of years ago, showing us what they looked like in the early universe. But these galaxies don't look young and primitive like we'd expect. Instead, they appear to be mature, fully formed spiral and elliptical galaxies with characteristics that should have taken much longer to develop. It's as if someone fast-forwarded cosmic evolution in this particular region of space, allowing these galaxies to reach advanced stages of development in a fraction of the time it should have taken. The implications of this discovery extend far beyond astronomy. If confirmed, this structure could force us to reconsider some of the most fundamental assumptions about physics itself. The laws that govern how matter and energy behave on cosmic scales might need to be revised. Our understanding of dark matter and dark energy, those mysterious components that make up 95% of the universe, could require complete overhauls. Some researchers are even speculating that this structure might represent evidence of physics beyond our current standard models. Could there be additional dimensions of space that we don't normally perceive? Are there forces operating on cosmic scales that we've never detected? These might sound like science fiction concepts, but when faced with observations that don't fit our existing theories, scientists have to consider all possibilities. The response from NASA and other space agencies has been telling. Rather than the usual excitement and immediate press conferences that typically follow major discoveries, there's been an unusual silence. Press releases have been minimal and carefully worded. Scientists who would normally be eager to discuss their findings are being surprisingly tight-lipped. This behavior is completely out of character for the normally transparent scientific community. Behind the scenes, however, sources indicate that there's intense debate about how to present these findings to the public. Some argue for full transparency, believing that such a significant discovery belongs in the public domain immediately. Others worry about the potential for misinterpretation and the impact on public confidence in scientific institutions. There's also concern about how this discovery might be received by various religious and philosophical communities, given its implications for our understanding of cosmic origins. The technical details of the structure are equally fascinating. Spectroscopic analysis of the galaxies within the formation reveals unusual chemical signatures that don't match what we see in comparable structures elsewhere in the universe. The distribution of elements suggests stellar formation processes that operated differently than we observe in our local cosmic neighborhood. Even the colors and brightness patterns of these galaxies follow rules that seem to be unique to this particular region of space. What's particularly puzzling is the structure's apparent stability. Normally, such a large-scale formation would be subject to gravitational forces that would cause it to either collapse inward or disperse outward over cosmic time. But this structure appears to have maintained its organized configuration for billions of years, suggesting the presence of some stabilizing mechanism that we don't currently understand. Computer simulations attempting to recreate the formation and evolution of this structure have so far failed to reproduce what we observe. Even when researchers input various exotic physics scenarios, additional particles, modified gravity theories, or alternative dark matter models, they can't get their simulations to produce anything resembling what Webb has captured. This suggests that we might be dealing with phenomena that are truly unprecedented in our understanding of cosmic evolution. The discovery is also raising questions about how many similar structures might exist elsewhere in the universe. If this formation represents a new class of cosmic architecture, it's possible that there are others scattered throughout space that we simply haven't detected yet. The James Webb Space Telescope's incredible sensitivity and resolution might be revealing a hidden layer of cosmic organization that previous instruments weren't capable of seeing. This possibility is both exciting and unsettling. If there are multiple such structures throughout the universe, it would suggest that our current cosmological models are missing some fundamental component. We might be looking at evidence of processes that operated during the earliest moments after the Big Bang, leaving their fingerprints in the large-scale structure of space itself. The international astronomical community is now racing to obtain additional observation time on Webb and other advanced telescopes to study this structure in more detail. Every major observatory on Earth is being pressed into service to gather complementary data. Radio telescopes are scanning for unusual emissions from the region. X-ray observatories are looking for signs of exotic high-energy processes. Even gravitational wave detectors are being monitored for any signals that might be associated with this cosmic anomaly. Meanwhile, theoretical physicists are working overtime to develop new models that could explain what we're seeing. Some are exploring modifications to our understanding of dark matter, suggesting that it might interact with ordinary matter in ways we haven't previously considered. Others are investigating whether the structure could be evidence of cosmic strings, theoretical one-dimensional defects in spacetime that could have formed during the universe's earliest moments. There's even speculation about whether this structure might be connected to the mysterious dark energy that's causing the universe's expansion to accelerate. Could this formation be a relic from an earlier phase of cosmic evolution when dark energy behaved differently? Or might it represent a region where dark energy's effects are somehow modified or amplified? The more scientists dig into the data, the more questions emerge. The structure's galaxies show evidence of having experienced synchronized star formation events, as if something triggered stellar birth across the entire formation simultaneously. This kind of coordination across hundreds of millions of light-years should be impossible according to our current understanding of cosmic communication and causality. Some researchers are beginning to wonder whether we might be looking at evidence of processes that operated before cosmic inflation, the rapid expansion that occurred in the universe's first fraction of a second. If so, this structure could be a window into physics that existed before the mechanisms that shaped the rest of the observable universe took hold. The public's reaction to the limited information that has been released has been intense. Social media is buzzing with speculation about what NASA might be hiding and why they cut the feed so abruptly. Conspiracy theories are proliferating, ranging from cover-ups of alien civilizations to evidence of parallel universes. While these extreme interpretations are almost certainly wrong, they reflect the public's frustration with the lack of transparent communication about such a significant discovery. Scientific institutions are now grappling with how to balance the need for careful analysis with the public's right to know about discoveries made with taxpayer-funded instruments. The James Webb Space Telescope cost over $10 billion and was built with public money specifically to advance our understanding of the universe. Many argue that the public has a right to access the data and participate in the excitement of discovery, even if the implications aren't fully understood yet. As we wait for more information to emerge from official channels, independent researchers are working with the limited data that was captured before the feed cut. They're using every analytical tool at their disposal to extract maximum information from these precious observations. What they're finding continues to challenge our fundamental assumptions about how the universe works. The structure appears to be threaded through with what researchers are calling connectivity patterns, arrangements of matter and energy that seem to facilitate communication or interaction across vast distances. These patterns don't correspond to anything we've seen before, and might represent entirely new physics operating on cosmic scales. Looking ahead, this discovery is likely to reshape the field of cosmology for decades to come. Graduate students are already retooling their research projects to explore the implications. Senior scientists are reconsidering theories they've spent their entire careers developing, and funding agencies are scrambling to support new research directions that might help explain this cosmic puzzle. The James Webb Space Telescope will undoubtedly return to study this structure in greater detail once the initial analysis is complete. But even with our most advanced instruments, it may take years or even decades to fully understand what we're looking at. This discovery represents the kind of paradigm-shifting observation that comes along perhaps once in a generation, forcing us to fundamentally reconsider our place in the cosmic order. What makes this moment particularly significant is that we're living through it in real time. Previous revolutionary discoveries in astronomy often took years to be recognized for their true importance. But in our connected world, with advanced instruments and instant global communication, we're witnessing the immediate impact of a discovery that could redefine our understanding of reality itself. The fact that NASA felt compelled to cut the feed tells us everything we need to know about the magnitude of this discovery. This isn't just another interesting astronomical observation. This is something that has the potential to shake the foundations of modern science. And while we wait for official word on what exactly was found out there in the depths of space, we can be certain that our universe is far stranger and more wonderful than we ever imagined. The story of this massive cosmic structure is still being written. As more data becomes available and scientists work to understand its implications, we'll continue to follow every development. Because what the James Webb Space Telescope has shown us is that even after centuries of studying the cosmos, the universe still has the power to surprise us in the most profound ways possible.